Hello grade 7s, welcome to the second part of today's lesson, pure substances and mixtures. This can be found on page 81 of the textbook. So a pure substance is defined as having either the same atoms or the same molecules throughout. This would mean that it has the same physical properties throughout. In the example in the textbook, we have gold with chemical symbol Au, and that is just a bunch of Au atoms bonded together. That would be pure gold. Another example of a pure substance, this time comprising the same molecule throughout, is water, and the molecule is H2O. So in a glass of pure water, we would just have H2O molecules floating around. Now onto a mixture. A mixture is when we combine two pure substances together, but the pure substances don't react with each other chemically, and they maintain their original physical properties within the mixture. So examples of this, I've mixed together two solids, sand and paper clips. Sorry, you can't see it that clearly, but basically within this mixture, the sand and the paper clips maintain their identity. They don't react chemically. And that means we can separate out the mixture physically. I can either put it through a sieve or I can pick out the paper clips with my hand. Next, we have a mixture of a solid and a liquid. So I'm just mixing together some salt and water. So even though the salt will eventually dissolve and disappear within the water, each substance still maintains its identity, its original physical properties. So we will just get a salty liquid. Next, we have a mixture of a liquid and a gas. This is carbonated water. And the carbon dioxide separates from the water in the form of gas bubbles. Next, we have a mixture of a solid and a gas. This is styrofoam, and in between the polyester, there are air bubbles that have been trapped. So the air bubbles are what allows this solid to float. So now I'd like to move on to some examples from the textbook. This is activity 2 on page 81. First question, identify which of the diagrams below show mixtures and which do not. Sorry. Provide reasons for your answers. So to do this kind of question, we need to remember our definition for a mixture, which is either different atoms or different molecules. For 1A, we have pink atoms and red molecules. So that's two different types, and this would be a mixture. For B, we have the same molecules throughout, the same red-blue throughout. So this is a pure substance. For C, we once again have a mixture, pink atoms and red-blue molecules. For D, we also have a mixture, two different kinds of molecules, the red-blues. Question 2, identify which of the photographs below shows mixtures and which do not. So 2A is a fruit salad, classic example of a mixture. Each piece of fruit is separate. 2B, that also looks like that looks like pure substance, sorry. That could be either pure salt or pure sugar. C also looks like a pure substance, could be pure water. D looks like a classic example of a mixture, so it's visible that there's sand mixed together with some other rocks, different sizes, different colors. So that concludes today's lesson. I'm going to send some additional questions in a worksheet form to go together with what's in the textbook, because the textbook has very little. And in the next section, we'll be covering how to separate mixtures. So because the mixtures didn't combine physically, we can separate them with physical means. And this is the next section starting on page 82. I'd like you to please maybe read a little bit ahead, just to see what we're going to be doing. And yeah, that concludes the lesson for today. I hope you have a happy Monday and good luck. Please message me if you don't understand.